This is part 9. It's about solving polynomial inequalities. So we'll just review a little bit about polynomial equations first before we do this example. For example, if you had x plus 1, x minus 2 equals 0, and we want to solve this equation, we set each of the factors to 0. X plus 1 equals 0. That means x is minus 1. In this case, x minus 2 equals 0. So x would equal 2. Now, if you were to make a number line of this solution, where this is the set of all real numbers, a real number line, we'll put 0 here. 1, 2, 3. 1, 2, 3. So 1, 2, 3, minus 1, minus 2, minus 3. So for example, in this case, x equals 2. So here we put a solid dot, and x equals minus 1 is here. So that would be your answer if you are to make a number line. But normally when we solve equations like this, we don't bother with a number line, okay? But when we do inequalities, we actually need a number line. So let's have a look. So let's imagine we have a simple inequality, x squared is less than or equal to 4. So I want to know what numbers, when you square them, the answer will be less than or equal to 4. So what we do, we make a number line. Let's try a few numbers. 1, 2, 3, 4. 1, 2, 3, 4, add negative. So let's choose 0. Is 0 squared less than or equal to 4? Yes. So I'll put a tick there. How about 1? Is 1 squared less than or equal to 4? Yes. How about 2? 2 squared less than or equal to 4? Yes, because 4 is less than or equal to 4. They are equal. So yes. But what about when we go to 3? 3 squared is going to be 9, which is not less than 4. 4 squared is 16, not less than 4. So you're not going to find any more that are correct in this direction. Okay, they're all going to be wrong. How about minus 1? Minus 1 squared is 1. Is 1 less than 4? Yes. Minus 2 squared is 4. So that's true. Minus 3 squared is 9. We have the same problem as this side. 9 is not less than 4. So these are going to be wrong in this direction. So we can see our solution is going to be these numbers in here, including fractions. So if you put a half in, a half squared, less than or equal to 4. A half squared is a quarter, which is also less than or equal to 4. So any real number between minus 2 and 2 is a solution to this question. So if your question is x squared less than or equal to 4, our solution we would write as minus 2 less than or equal to x less than or equal to 2. This is how we write this solution here. This is telling me all x values between minus 2 and 2. So in example 15, we want to solve this quadratic inequality using algebraic methods. I put a graph here because we can also do the question by graphing methods, which I'll show after. So we've got a quadratic, and it's an inequality because you see an inequality sign here. So the first thing you do, x squared plus 2x. I want you to put the 8 on the other side to make it look like a quadratic. So minus 8 less than or equal to 0. So if there's any numbers on this side, move them across and make a quadratic here. Now this looks like something we can solve. So what you do, let x squared plus 2x minus 8 equals 0. I want to find what I call the critical points. and I'll write them down in a minute. So can we factorize this? We'll have x plus 4 and x minus 2 equals 0. Okay, so this is correct, isn't it? 4 times minus 2 is minus 8. 4 plus negative 2 is 2. So we have our correct factors. And then we will write the solution. So that means x must be minus 4. And in this case, x would equal 2. These are called your critical points. And you'll also recognize these to be the solution to this equation and also the x-intercept in the graph, which we'll do later. So the next step, we make a number line. So we put a number line in, and I mark these critical points on the number line. So let's put a 0 in, and then we go to 2, let's go to 3, 4, 1, 2, 3, 4, and go in the other direction, minus 1, minus 2, minus 3, minus 4, let's go to minus 5. Okay, so what we want to do is find out where our original inequality is true and where it's false. So x squared plus 2x minus 8, and the question was less than or equal to 0. So where is this going to be true? On this axis here, on the x-axis. So we put our critical points on. So we've got 2, which is this one here. 2 will be true. If I put 2 in here, I'll get 0. And because I have an equals here, that means it will be true. So I colored the dotted in solid here. So the other critical point is minus 4. There. So if I put minus 4 into this inequality, it will also be true because they'll be equal to 0. But now I want to know what is happening in the middle and what is happening on the sides. Are they going to be true or false? So let's take 0. If you put 0 into your inequality, will this be true or false? So you'll get 0 squared plus 2 times 0 minus 8 less than or equal to 0. Will this be true or false? This will be 0 minus 8 less than or equal to 0. Is this true? Yes, true. This is true here. Now, we can check these other numbers. They are also going to be true because they lie between the critical points. So if you find one number that is true, all of these numbers here are also going to be true. You don't need to test them. But what you should do now is test another number like 3. So let's try a number on the other side of this critical point here. So put them in, 3 squared plus 2 times 3 minus 8 less than or equal to 0, true or false? 3 squared is 9 plus 6 minus 8. 9 plus 6 is 15 minus 8 less than or equal to 0. This is going to be false, isn't it? Because 15 minus 8 is a positive number. So 3 is false, which means all the other numbers are going to be false on this side here. So what we do now, go back to our other side here. I suspect that this side is also going to be false. So let's try minus 5. Minus 5 squared plus 2 times minus 5 minus 8 less than or equal to 0. Is this true or false? Minus 5 squared is 25. 2 times minus 5 minus 10 minus 8 less than or equal to 0. So you got 25 minus 18. And this is also false. 25 minus 18 is positive, and it's not less than 0. So on this side, these are also false on here. You can check some more if you want, but I guarantee if one is false, the remaining numbers on this side will also be false. And all the numbers in here will be true if you like to check them, but don't waste your time on that. They will be true. So our solution is actually going to be all the numbers between -4 and 2. So our solution is going to be all the numbers between -4, including -4, up until 2 here. We write the left number first. And because we're including 4, we have a equal sign, less than or equal, and we have another sign the same here. And then we write 2 on the other end. So this is telling me all numbers between -4 and 2 inclusive. So all numbers between -4 and 2 inclusive, including the n number. There. So this is your answer, and that's what you write for the question. Now, if you're going to do the graphing method, we can also do it. Notice that our critical points are -4 and 2. So I put them on the graph. 2 is here, then -4, -4 is here. Notice that this is a quadratic, and the family is the x squared family. So we know the graph will pass through the critical points, which are the x-intercepts, and also our y-intercept is -8. Put that in down there. So we'll go down here somewhere and go up. So we'll get a graph like that. So I want to know, where is our graph going to be negative, less than 0? So let's just write that as px. So on this line, px equals 0, doesn't it? On this line. And we got our solutions, x is 2 and -4. But above the line, the polynomial will be positive, greater than 0, because this is the positive direction, right? And below the axis, below the x-axis, the polynomial will be less than 0. So if you look at our question, this says less than 0. Okay, and less than 0 is here, less than or equal to 0. So the graph is here, right? This is below the axis. So the important bit is this part here. You see? So we're actually going to get the same solution. That purple line there is -4, including -4. So I put the equals here, x2. This is actually a lot quicker than doing this critical point analysis here and checking if they're true or false. I don't mind which you do in the test. And if you want to practice both on the homework, you can do that and I'll check them. So in exercise 9, we use the same method. You can do graphing method or you can do the algebraic method. So I'll start you off here. So the first thing you do, let's let that equal to 0, right? So just change your inequality to equals. And then we factorize x, that would be 6 times -3, right? Yeah. So 6 times -3, -18. 6 plus -3 is 3. So the critical points, which are your x-intercept, would be -6 and 3. So you get your critical points, make a number line, put 0 in, and then we've got 3 on this side, and we have -6 on this side. Okay, and because we're including being equal to 0, we can include -6 and 3 in the solution because you have an equal sign in the question here. So we include 3 and we include -6. So if you check 0, put 0 into your question, will it be true or false? Okay, and then you just follow as the previous example. We can also use the same algebraic method to solve these higher degree polynomials. And you can see here we have a cubic polynomial. So let's write it out. X plus 2, x minus 1, x minus 3. So let this equal to 0. And this will give us the critical points. So in this case, the critical points will be -2, 1, and 3. So once you have your critical points, make a number line, put a 0 in, 1, 2, 3, 4, and then -1, -2, -3. Okay, so if you notice the sign is less than, okay, which means that these critical points are not part of your solution. So that means we have to make 1 as an open circle here. So 1 is not part of your answer. If I put 1 in here, I'll get 0, right? And 0 is not less than 0. And the same for the other two numbers. So 3 can't be included and -2 can't be included. Okay, so now we need to check some areas in the graph. So we've got 3 areas. Let's mark them out. This one, and we've got this area, and we've got this area here, and this area here. And we want to know, where is your inequality true or false? So I'm going to write your inequality again. X minus 1, x minus 3, less than 0. So true or false. So let's look at the yellow part first. So -3, let's try this number. And put -3 into your inequality. So -3 plus 2, -3 minus 1, -3 minus 3. Is that less than 0 or not? True or false? So -3 plus 2, -1, -3 minus 1, -4, -3 minus 3, -6. So -1 times -4 is 4. 4 times -6 is -24. Is that less than 0? Yes. So this is true, this area here. So then we'll do the same for the blue part. Choose a number. 0 is easy, right? Because there's not too much calculation involved. So take 0. So 0 plus 2, 0 minus 1, 0 minus 3. Is that less than 0? So you go 2 times -1 times -3. Less than 0. -1 times -3 is 3. 2 3s are 6. So false. So 6 is not less than 0. Okay, so this area in blue will be false. Let's do the green. So for green, an easy number here will be 2. So put 2 in. 2 plus 2, 2 minus 1, 2 minus 3, less than 0. 2 plus 2 is 4. 2 minus 1 is 1. 2 minus 3 is -1. So 4 times 1, 4. 4 times -1 is -4. So that's going to be true. So the green area is true. So let's check the purple area. Easy number to use here, 4. You can use any number you like that's more than 3, but let's try 4. So 4 plus 2, 4 minus 1, 4 minus 3, less than 0. 4 plus 2 is 6. 4 minus 1 is 3. 4 minus 3 is 1, less than 0. 6 threes are 18. 18 less than 0, false. So this area would be false. Okay, so we'll write our solution out. So looking at our graph, what is true? Any number less than minus 2. So x is less than minus 2, or you can be between 1 and 3. So notice we don't include the minus 2 here, and we don't include the 1 and the 3 here. So you can write your solution like that. There are other ways to write your solution, but for this time, this is okay. So just write it out like that. If you're going to do the graphing method, we can still do it and get this answer here. So let's try. So you take your critical points and you write them on the graph. Minus 2, you've got 1 here, and you've got 3 here. Notice your family of graph is an x cubed graph. And x cubed graphs start at this top on the right and they'll end down on the left side down the bottom somewhere. And so we need to make a cubic graph going through those critical points, which are your x-intercepts. And what is y-intercept? 2 times minus 1 minus 2 times minus 3 is 6. So that's your y-intercept, so up here somewhere. So let's make a graph. Through 3, turn somewhere, go up through 1, and then go through your y-intercept, then go down through minus 2 like that, okay? So that would be the graph of this polynomial, px. And we can write it out, x plus 2, x minus 1, x minus 3. So you know how to graph these already. So we just draw the graph of the polynomial. And then the question, where is your polynomial value negative, less than 0? So if you look at our graph, where is the graph less than 0? Remember, this is where px is less than 0. Px on the x-axis equals 0, and px greater than 0. So where is it negative? Where is it down here? Which means all of this area down here. So we will see our graph here, there, and also there. So you can see we're going to get the same solution. This here, let's do an open circle because we don't include those numbers. So we've got less than minus 2, or in this area between 1 and 3. Okay, so it's up to you which method you use. This test point method is better when we learn more inequalities later on, because some graphs, for example, graphs of rational functions, are quite difficult to draw, and we'll be using this method, and also for absolute value inequalities as well. So I recommend to use this test point method here, using the critical points. But graphing you can use for polynomials. This is exercise 10. Have a go at these questions. Notice that these are already factorized. Okay, so you don't have to do any factorization. Just follow the example here, example 16 for those two. Same here. We've got more questions that are already factorized, and E and F are already factorized. But in these questions, you need to factorize first. Okay, so the first one's quite easy. You'll have x squared minus 3 greater than 0. We can factorize this using difference of squares. We'll have x squared minus root 3 squared, because root 3 squared is 3, okay? Like that. So you'll have x minus root 3, x plus root 3. That's just a hint how to do that one. And you'll have your 3 critical points here. So you'll get 0 from the first one, you'll get root 3 from this one, and minus root 3 from that one. And then you put them on your number line. So 0, root 3, minus root 3 here. Okay, I've started that one for you. This one you need to factorize. And it's a cubic, so more than likely you'll get 3 factors. So you can draw the solution over here somewhere before you solve it. And the same with these two, you need to factorize them first. And E and F, these are quartic polynomials, are factorized as normal. And you may end up with 4 factors here. Okay, it could be 4 factors. So check that out and see what happens. Okay, try those questions and I hope to mark them soon. Thank you.